So now we'll be dealing with how to perform A star search, and we'll be taking an example question and to learn it. So basically A star search is a searching algorithm that uses the concept of a heuristic function. Heuristic function is basically a value that determines that how it's basically how it determines that how the node is nearer to the endpoint. This is what you can say is heuristic function in layman terms. So heuristic function is basically an additional cost which helps determine an optimal path to the node. So it basically assigns importance to the node. That's how a heuristic function works. So for the numerical part, we'll see that the cost of a node is calculated by Fn equals to Gn plus Hn. Okay, so Gn plus Hn. Gn is the cost to reach that node normally, like the cost that has been given, and Hn is the heuristic. So what I have done is, this is an example question. S is the start, G is the goal, H is with cost. So we have SA2, SBC, SB4, so SA2, SBC, SB4, ABC, and AE4, and AE5, AD3 and AE5. Okay, so the cost is AE5, AE5, then BE1, and then BF4, and then CF2, and CG6, and then BG7, and EG6, and FG2. So this is how the question is mapped. And the heuristic values are determined in Z. So the heuristic value for S is 8, A is for A is 6, for B is 5, for C is 4, for D is 5, E is 3, F is 2, and for G is 0. So these are the values that are provided to us in the question. Now to perform A star search and find the optimal path from S to G, we need to use the concept of the heuristic function, which is how the cost is calculated for a node in A star search, Fn equals to Gn plus Hn, and we utilize the concept of an unexpanded frontier. So basically, unexpanded frontier is a priority queue that maintains what all nodes have been expanded and what are yet to be expanded. I think it does not mean what all have been expanded, but it does maintain the queue of what all is coming next based on the least cost. So that is based on least cost. So not jumping into technical jargon, let's move on with the example. So this is our example, and we need to find the optimal path from S to G. So let's start. So since our start is S, so we start from the S node. So this becomes our case 1. So let's say step 1, expanding S. Okay. So to expand S, we'll see that it has 3 nodes A, B, C. So it has 3. So let's say we take node A. So the formula that needs to be kept in mind is Fn equals to Gn plus Hn. So Gn is the cost. So from S to A, the actual cost of reaching is 2. You can see the cost of reaching is 2. So this is 2 plus Hn, the heuristic function for A. The heuristic function will be taken off to where the node is reaching, to where we are going. So we're going to A, so the heuristic function of A will be, the heuristic function of A is 6. So 2 plus 6. So the Fn for node A equals to 8. Similarly, we calculate this for node B, 2 plus 6. For it was, so for B, the cost is 3, and the heuristic function is 5. So the final answer is 8. And for node C, we can see the cost is 4, and the heuristic function is also 4. So 4 plus 4. So we can see all the values are coming out to be 8. Let me just this here. Okay. So we can see that all the values are same. So in this case, the question specifies, the condition is not copied here, but in this case, the ties will be broken alphabetically. Ties will be broken alphabetically. in the alphabet, A comes before A, B, and C. So A node will be chosen. So node A will be chosen. So currently our path that we noted down. Uh, so the current path is S to A. We have moved on. We have started from S and we have expanded A. Okay. So in that case, we will expand A. So if A has been expanded, so step 2, we have expanded A, so the remaining nodes that are remaining along with their cost will go into the unexpanded frontier. So B comma 8 and C comma 8. These will go in the unexpanded frontier because these are unexpanded, and we'll expand as A because we have chosen A. Okay, so now we can see A has how many nodes? A has D and E. So similarly, node D. So since we are starting from S, so we'll take the cost of reaching to reach node D from S because we have started from A. So from if we go from S to A and then to D, the cost that will be taken is 2 because S to A the cost was 2 and from A to D the cost is 3. So 2 plus 3 is 5. So the normal cost to reach node D is 5 and the heuristic function of D is 5 as well. So the node D has a value of 10. Similarly, node E. So in this figure, if we look at here, we always start from S. So to reach E and from S we went to A. So the cost that was accumulated was 2. And from A to we went E and the cost that was accumulated was 5. So 2 plus 5 is 7. So for node E the cost is 7 and the heuristic function for node E was 3. So 10. Once again, uh, both our values are same. So the tie would be broken alphabetically. But before that, we need to push these into the unexpanded frontier. So this process should have happened in A as well. So like A should have been also pushed in the unexpanded frontier. And then among these, the alphabetical tie would be broken and we would have popped out A. So similarly, after we calculate the heuristic function, we push them into the unexpanded frontier. So D with its value of 10 and E with its value of 10 as well. Now we can see that unexpanded frontier, we expand the least cost first, and the least cost have been B and C. Have been with B and C. So we need to calculate. Uh, we need to see that B would be expanded first because A value has with B and C, and among B and C, the alphabetical tie that will be broken with what we choose B. So D and E will be in the unexpanded frontier, but since we have a lesser cost node available in the unexpanded frontier, we'll choose that. So we'll choose B. So B will be popped out and an unexpanded frontier will remain here. So now we'll be expanding B. Step 2, expand B. So since we'll be choosing a different path, so currently maintaining this path is not feasible. So let's say we'll arrive at another path. So since B was a parent node of S, so we'll try for another path. Now we are going with B. So these are the cases that we need to try while we expanding. So now we'll be expanding B. So let's say B has two children, E and F. So the node E and F, we will calculate the function cost for them. Node E. So the total cost to reach from node E, and now the path we are following is we went from S, then we went to B, and then we are going to E. So the cost to reach from S to B to E is 3 plus 1, so it's 4. And the heuristic function of E was 3. So the cost to E as we reach node E was 3 plus 1, 4, and the heuristic function of E was 3, which comes out to be 7. And node B has another child F, so node F. So the cost to reach node F would have been from S to B to F. So 3 from S to B and 4 from B to F. So 3 plus 4 is 7. So the cost is 7 and the heuristic function value of F is 2. So 7 plus 2, 9. So now pushing these into the unexpanded frontier. So we can see that node E is already present, but node E has a value of 10. So what we'll do, we'll push the node E and we'll update its value. So node E will get updated and node E will now have a value E7. E7. And node F will also get pushed and now it will have a value of 9. So now we have these 4 nodes in the unexpanded frontier and we need to choose which of them have the least cost. So we can see out of 8, 10, 7 and 9, 7 has the least cost. So this value will be chosen and E will be expanded because it has the least cost. So step 4, expand E. Now I can see that we chose E when it was a child of B because the cost 7 that occurred, it came when it was a child of B. Because when node E was a child of node A, the cost was 10. So we will not choose that one. We chose the value of E when it was a node of B. So we'll update our testing path here and we'll write that we went to E from B, not from A. Because we could have gone to E from A, but we went from B because the least cost that came out, that was 7, that came when we expanded node B, not node A. So this is our testing path for now. Now we'll go down now and we'll expand node E. So node E only has a single child, node G. So to reach the cost, so with the path that we took was we went from S, B, then E, and then we are going to G, which is the sole child of node E. So from here to here to here, the cost that arose was 3 plus 1 plus 3. So 6 and 7. So the cost to reach node G was 7. So node G, the cost to reach was 7 and the heuristic function of G is 0 because it is the target value. So 7. So this is our value and we have reached node G because the question says that we need to reach node G. G is the goal. So as soon as we reach G, we can stop and because we found the minimum path that we have to follow. So G, so the path that we would have chosen would be F, D, E, G. And the minimum cost that would have taken us to get here. So G has a cost of 7. So we have reached the node G. We have started from S. We have started from S and we have reached node G and it all took a total cost of 7. Because the final answer of our, the value that needs to be pushed in the expanded frontier is 7. So we reach and the final value is 7. So this is how A star search works. We need to compute the function, the function which consists of the actual cost and the heuristic value. And we need to maintain this unexpanded frontier, which helps us determine that which node to expand. So this is how the A star search algorithm works, and we have wrote these nodes B. So the final path that would be followed would be S, D, E, and G, and with a cost of 7. This is how A star search works.